You picture space as empty, cold maybe, but basically nothing. You imagine temperature needing stuff. Atoms, motion, collisions. You imagine heat as something that belongs inside matter. So you assume empty space can't have a temperature. Because what would be warm, what would be cold? That picture feels obvious, comforting, it feels settled. But it's wrong, not subtly wrong, fundamentally wrong. Because when physicists actually measure the universe, they don't find zero. They never find zero, even where there is nothing to touch, nothing to collide, nothing to stir. Space itself carries a number, a temperature, a quiet one, and the moment you accept that number is real, your mental image of emptiness collapses. Because now nothing is doing something, everywhere, all the time. You were taught to expect zero, not explicitly. No one ever said it out loud, but it settled into your thinking anyway. When you imagine empty space, you imagine absence. No particles, no motion, no activity, and from that picture, zero feels inevitable. Temperature, after all, is taught as movement. Atoms vibrating, molecules colliding. More motion means hotter, less motion means colder. So when there is nothing moving, you expect no temperature at all. Absolute zero, the end of the scale. This feels so natural that it rarely gets questioned. Even the language reinforces it. Cold as space, frozen vacuum, dead silence. All of these phrases quietly agree on one thing: emptiness equals stillness. But notice what just happened. You imported a rule from matter and applied it to the absence of matter. That step feels harmless. It feels logical. It isn't, because temperature was never defined as stuff banging into other stuff. That was a shortcut, a classroom crutch. It worked because most of your experience happens inside matter, air, metal, skin. So the definition bent itself around those examples. But physics does not care where your intuition came from. When physicists say temperature, they are not describing how busy atoms look to you. They are describing how energy distributes itself among possible states. That distinction sounds abstract, so your mind pushes it away. Instead, it clings to the picture you know. Empty space equals zero. And once that picture locks in, everything else feels obvious. You stop asking questions before they form. If space has nothing, it must have no temperature. If it has no temperature, measuring it is meaningless. If measuring it is meaningless, the idea never comes up. A perfect loop, comfortable, self-sealing. But the universe does not honor this agreement, because the moment you actually try to define zero, operationally, not philosophically, not poetically, but physically, the idea starts to fall apart. And the fall doesn't begin in deep theory, it begins in measurement. In the next step, we don't change the definition yet. We don't introduce new ideas. We simply ask a dangerous question. What happens when you go looking for zero and reality refuses to give it to you? Imagine you are not trying to be clever. You are not trying to overturn philosophy. You just want to measure. You point an instrument into deep space, far from stars, far from dust, far from anything you would call matter. If your intuition were right, the instrument should read nothing. No signal, no temperature, silence, but it doesn't, it never has. Every attempt, from the earliest radio measurements to modern satellites, returns the same kind of answer. There is always energy there. Tiny, uniform, persistent. At first, this looks like error. The obvious explanation is contamination. Leftover heat from stars, radiation bouncing around, bad instruments, human noise leaking into the data. So physicists subtract, they correct, they shield, they improve, and every time they do, the signal remains. Not chaotic, not directional, not localized, the same in every direction. This is where intuition starts to slip. Because if the energy were coming from objects, it would point back to them. If it were coming from motion, it would vary with location. It does neither. The universe is expanding, cooling, thinning out, and yet this background refuses to vanish. You are tempted to say, it's just leftover, a historical accident, a fading echo, but even an echo should fade into nothing eventually. This one doesn't, and here's the uncomfortable part. Physicists can assign it a temperature, not metaphorically, not poetically, numerically. They can say, calmly and precisely, that empty space sits just a few degrees above absolute zero. The number is small enough to ignore emotionally, but not small enough to dismiss physically, because zero is not a suggestion. Zero is a boundary. Cross it, and the definitions break. Approach it, and the rules become fragile. And space never reaches it, no matter how far you go, no matter how empty the region looks, no matter how patiently you subtract everything you think belongs there. This is not what your mental model predicts. Your model says temperature needs things. Your instruments say otherwise. So now you have a choice. You can cling to intuition and treat the measurement as a nuisance. Or you can accept the measurement and admit something deeper is wrong. Physics always chooses the second option, because measurement is not an opinion. It is reality speaking in numbers. And when reality speaks calmly, consistently, and everywhere at once, it is usually pointing at a rule you haven't learned yet. In the next step, we don't explain the source. We do something more unsettling. We ask whether your idea of temperature itself was ever tied to matter in the first place. This is where intuition resists hardest. Because you were taught that temperature is about contact, about collisions, about things hitting other things. Hot means fast particles, cold means slow ones. So if there are no particles, there can be no temperature. That story feels complete. But it quietly smuggles in an assumption that temperature belongs to objects. Physics never made that promise. Temperature is not a property in the way mass is. You don't point to it and say, that object owns it. Temperature is a description, a statistical one. It tells you how energy is spread out across the possibilities a system allows, not how busy something looks, not how crowded it is, how energy distributes itself when it has freedom. This is subtle, and your intuition hates it. Because you don't feel distributions, you feel warmth on skin, you see steam rise, you hear metal crack. So your brain insists on touch. But physics does not require contact to define temperature. It requires available states. If a system has ways to carry energy, temperature becomes meaningful. And here is the uncomfortable turn. Space has available states. Not objects, not particles in the everyday sense, but fields. Everywhere you look in modern physics, reality is described not as isolated things, but as fields filling space. Electric fields, magnetic fields, quantum fields. Even when there are no particles present, the fields remain. And fields can hold energy, not in lumps you can grab, but in fluctuations, tiny variations, constant motion around an average that never settles. You don't see this motion, you infer it, because if it were absent, your measurements would finally drop to zero. They don't, so temperature, in this deeper sense, is not telling you stuff is moving. It's telling you that space itself cannot stop allowing energy to spread. Even when nothing is happening, something is permitted to happen. This breaks a deeply held picture. You wanted emptiness to be inert, featureless, silent, but temperature does not care about your imagery. It only cares about possibility, and space, it turns out, is full of it. In the next step, we confront the most stubborn illusion of all, that this background energy is accidental, that it could be turned off. At this point, the mind looks for an escape. You want the temperature of space to be optional. A leftover, a remnant from a violent past, something that just hasn't faded yet. That way, emptiness can remain pure in principle, even if the universe hasn't waited long enough. This is the last comfortable position, and it fails. Because the background energy of space is not messy, it is not irregular, it does not carry scars of events, it is smooth, uniform, everywhere. If you remove galaxies, it remains. If you remove stars, it remains. If you imagine a universe emptied of structure, it still remains. This is not what leftovers look like. Leftovers are uneven, they clump, they point back to causes. This does not. Physicists call it a background not because it is secondary, but because it is unavoidable. You don't detect it the way you detect an object. You run into it no matter what you do. Lower the noise of your instruments, it is still there. Cool your detectors, it is still there. Move to deeper space, it is still there. And crucially, it behaves like a thermal system. Not metaphorically, not loosely, precisely. Its spectrum matches what temperature demands, not any temperature. A specific one. This is the moment where intuition gives up and labels it mysterious. But mystery is not an explanation. The deeper issue is structural. For space to have a temperature everywhere, the universe must enforce it. Not as a law written somewhere, but as a consequence of how reality is allowed to exist. You cannot subtract this background without subtracting space itself. And even that thought turns out to be incomplete, because the moment you imagine removing it, the framework you are using collapses. Space without this quiet energy is not stable, not mathematically, not physically, not conceptually. This is where empty stops meaning what you think it means. Emptiness is not a state you can reach by erasing things. It is a structure with rules, and one of those rules is, it refuses to be cold. In the next step, we stop treating this as a passive fact and confront a deeper claim. Space is not merely carrying temperature. It is actively preventing zero. Here is where the idea becomes uncomfortable in a different way. So far, space has been quietly warm, annoyingly non-zero, persistent. You could still imagine it as passive, a container that happens to hold energy. But that picture breaks next, because the universe does not merely allow space to have temperature. It enforces it. Try the thought experiment. Imagine you somehow remove every particle, every photon, every trace of matter and radiation. You do this perfectly, no cheating. What remains? Your intuition says nothing. Stillness, zero. Physics says instability, because a perfectly cold vacuum is not neutral. It is not a resting state. It is a configuration with nowhere for fluctuations to go, and reality does not tolerate that. At the deepest level, fields cannot sit exactly still, not because they are restless in a human sense, but because the rules that define them forbid total silence. If you demand zero motion everywhere, you violate the structure that allows the fields to exist at all. So the vacuum responds, not dramatically, not explosively, quietly, by reintroducing energy. Tiny variations appear. They cancel on average, but they never disappear. This is not randomness layered on top of emptiness. This is emptiness expressing itself. The vacuum is not a blank page. It is a system with constraints. And one of those constraints is this: it cannot be perfectly cold without ceasing to be meaningful. Zero temperature is not a natural destination. It is an edge case the universe avoids. So when you measure a faint warmth in space, you are not seeing a leftover mistake. You are seeing the minimum activity reality can sustain without breaking its own rules. This is why the background does not fade. Why expansion does not erase it, why time does not cool it away. Emptiness is doing just enough to remain emptiness. In the next step, we confront the consequence of this refusal. Because if space can never fully cool, then the universe itself never truly comes to rest. There is a comforting story people tell about the far future. The universe expands, stars burn out, everything thins and fades. Eventually, nothing happens, no light, no motion, no change, a perfect stillness. This story feels like a natural ending, a calm resolution. But it relies on an assumption you can no longer make. It assumes cooling has a finish line. If space itself carries temperature, then cooling does not end in silence. It asymptotically approaches a floor it never crosses. Even when all structure is gone, even when time has erased every process you recognize, the universe is still thermally active. Not busy, not dramatic, but not dead. This matters more than it sounds, because temperature is not just about warmth. It is about irreversibility. As long as temperature exists, there is a direction to time, a statistical arrow that refuses to vanish. You can slow change down, you can dilute it across unimaginable spans of time, but you cannot eliminate it. There will always be fluctuations, always rare events, always the faint possibility of something happening instead of nothing. The universe does not freeze into a final frame. It drifts endlessly. This destroys another intuition. You imagine the cosmos as a machine that eventually powers off, a battery that runs down, but machines stop because their components settle. The universe has no outside environment to settle into. Its baseline activity is internal, built in. So the far future is not a void at zero temperature. It is a thin, quiet world hovering above it, not changing in ways you would recognize, but never perfectly still. This is unsettling because it removes closure. There is no final equilibrium where nothing can happen. Only regimes where almost nothing happens almost all the time, and almost is not a technicality. It is the difference between an ending and an open question that never resolves. In the final step, we stop treating this as a physical curiosity and confront what it means for the idea of nothing itself. You started with a simple image, empty space, cold, inactive, a backdrop waiting for things to happen. That image is gone now, not replaced by a better picture, but by the absence of one, because nothing turned out to be a claim, not a location. Space is not what remains after you remove everything. It is what remains even when removal is complete. And what remains is structured. It has limits, constraints, minimum activity. A temperature not because it is heated, but because it cannot be otherwise. This forces a quiet shift in perspective. Reality is not built on objects floating in emptiness. Objects are disturbances in something that was already there. Something that never fully rests, never fully cools, never becomes irrelevant. You don't live in a universe suspended in nothing. You live in a universe suspended in a restless baseline that pretends to be empty only because its activity is too subtle to notice. And that baseline is not a flaw, not a leftover, not a mistake. It is the condition that allows anything else to exist at all. When physicists say space has a temperature, They are not adding a property to emptiness. They are admitting that emptiness was never empty. Not dramatically, not loudly, but fundamentally, and once you see that, the idea of nothing stops feeling like an end point. It starts to feel like a limit you can approach, measure, and never quite reach. Not because of ignorance, but because reality refuses to go there.